All right, good morning, 7th graders. We are on page 43, lesson 6, estimating probabilities using different types of simulations. So the first problem here, which spinner doesn't belong? And again, you can make a case for all of them as long as you explain your answer and not just circle one. You would be just fine in this problem. You could say the first one doesn't belong because it's the only one that has all equal choices. They're all equally likely. Top right one doesn't belong because the only has 3 outcomes. I guess all the others have 4. That's one thing you can note. Bottom left one doesn't belong because the red is actually bigger than the other 3 combined. Okay, and the bottom right one doesn't belong because you have 2 of them that are a quarter of the circle, and green is by far the smallest. Again, just being able to explain which one you chose, you can make a case for all of them. Question 2, Diego's walk. It says your teacher will give your group some supplies. We're going to simulate this experiment. And it says we can reach into a bag, we can use a spinner, we could roll 2 dice. Okay, and that's what we're going to do. So just kind of circle. If we get a sum, if the dice add up to 2 or 8, it means he has to wait. Okay, so we've done one of these problems before. So again, we're going to use the dice. Sum of 2 to 8 means that he has to wait. All right, so they did 3 here for us, and we are going to continue to complete the table. Okay, so 2 to 8 means we have to wait. Okay, so I got a 6. So does he have to wait? Yes. He already had to wait 2 days, so now that's 3 out of 4. Okay, and we'll figure out the decimals here as we go. Okay, 3 divided by 4, we should know that one is 0.75. Okay, rolling again. I got a 7. That is in that range again, so yes, Diego has to wait. So that would be 4 out of 5 days he has to wait, which is 0.8. Rolling again, I got a 9. Does not have to wait, so we're still at 4 days. Now we're at 4 out of 6, which is 2/3, 0.67. I got a 7. Yes, he has to wait. Now we're at 5 days. 5 divided by 7, 0.71. Okay, 11. That is no, does not have to wait. So now we're at 5 out of 8. 5 out of 8 is 0.63, 625 actually. Got a 6. Yes, has to wait. 6 days, that's 6 out of 9, which again reduces to 0.23. 9 does not have to wait, so we're still at 6 days, 6 out of 10, which is 3 out of 5, which is 0.6. Oh, that one went off. 7. Yes, has to wait. That's 7 out of 11. That is 0.64. 10 does not have to wait. We're still at 7. 7 out of 12. 0.58. 6. Yes, we have to wait. Now we're on 8. 8 out of 13, which is 0.62. 5. So yes, we have to wait again. Now we're at 9 out of 14. 9 divided by 14 is 0.64. And the last day, 8. Yes. So we're at 10 out of 15, which is 2/3 again. 0.67. All right. It does want us to graph it as well, so we're going to plot those points here as we go. Day 4 was 0.75. Day 5 was 0.8. Day Day 6 was 0.67. Day 7 was 0.71. Day 8 is 0.63. Day 9 is 0.67. Again, that's going to be a common one. The way it looks, they're all lining up. Day 10 is 0.6. Day 11 is 0.64. Day 12 is 0.58. Day 13 is 0.62. 14 is 0.64. And 15 is 0.67. So like we did this the last time, the more experiments we do, the more it should start to level off, and you can see that happening again. So question number 1 on page 45. Based on that data, would you expect your answer to be closer to, on the 16th day, 0.9 or 0.7? So if we do another experiment, do you think it's going to be closer to 0.7 or 0.9? Okay, well, if he has to wait, it'd be one more added on, right? It'd be 11 out of 16. So we could take 11 divided by 16, but hopefully you see that would be much closer to 0.7. Okay. Question 2, continue the simulation. All right, we are not going to graph them. We have plenty of data here if we had a little more time, but I don't want to make you just do it again. So we are not going to graph it, but I am going to just fill out the table for you. So right now we are at 10 out of 15, and we are looking for 2 to 8, remember. Okay, well, I got a 4, so that's a yes. Now we're at 11 out of 16. Got an 8, so yes, wait again. That'd be 12 out of 17. This would be a no. So we're still at 12 out of 18. 4, so that's a yes. That's 13 out of 19. 12 is a no, so we're still at 13 out of 20. No again, we're still at 13 out of 21. Yes, we're now waiting 14 days out of 22. We're at a no. So we're at 14 days out of 23. Went off the table there, sorry about that. Yes. That is 15 out of 24. And the last one is a no. So we're at 15 out of 25. So this one we already did. 12 divided by 17, 0.71. 12 divided by 18, again, that reduces to 2/3. 13 divided by 19, 0.68. 13 divided by 20, 0.65. 13 divided by 21, 0.62. 14 divided by 22, 0.64. 14 divided by 23, 0.61. 15 divided by 24, 0.63. And 15 divided by 25 is 0.6. So again, we'd start to see that leveling off somewhere around 0.6. And again, you can add that to your graph if you would like. Okay, so if you look at your graph, we're going to end around 0.6. So number 4, where would it be close to? I would estimate it would be good close to 0.6. Now, somebody else doing the experiment, you might have got closer to 0.7. That would be fine as well. Okay, next question. Let's just look at the Are You Ready? We're just going to do the first one here, so don't worry about 2. It says, after doing the simulation, a group finds that Diego has to wait 3 times. What is an estimate for the probability that Diego has to wait based on these results? Okay, well, 3 times he has to wait out of 4. So he has to wait 3 out of 4 times. Okay, if this group does one more simulation, what's the 2 possible outcomes? Okay, so wait. So let's say he has to wait one more time. So that's going to be another number here and another trial. So that's going to be 4 out of 5. Let's say you roll the dice and you didn't get a 2 to 8. If we did the same thing. So if he does not have to wait, he only has to wait 3 out of 5 times. Okay, for each possibility, estimate the probability he has to wait. So if this happens, he has to wait 4/5 of the time, or 80% of the time. If he doesn't have to wait, it's going to change our answer to 60%, or 0.6 of the time. So there's a pretty good variance because we didn't do that many trials. Okay, we only did 4 trials and then 1 more, so we did a total of 5 trials. You want to get a more exact answer, you had to do, we did 25 on the previous problem. Okay, more trials, the more accurate your simulation should be. C, what is the difference? Difference, remember, means subtract between the possible estimates after 5 simulations and the estimate after 4 simulations. Okay, so let's say you had to wait. So I'm going to take 4/5 minus what it would be after 4. Get a common denominator. So I gotta take this one times 4. Gotta take this one times 5. 1 over 20. Okay, which is a 5%. 1 divided by 20 is a 5% variation. Okay, that's the difference between those 2 numbers. Okay, now I'm going to subtract these 2 numbers. Okay, I know 3/4 is bigger, so I'm going to put that first. Common denominator. Take it times 5. Take it times 4, and I get 3 over 20, which is 0.15. Okay, so that's anywhere between a 5% difference. That's how much this one's going to go up, 75% to 80%, compared to this difference, which was 75% to 60%, which is a 15% difference. Again, the key is the more trials you can do, the more accurate your simulation will be. Okay, final question. Page 48. Describe a chance experiment that you could do. 6 people are going out to lunch. Which one gets to pick which restaurant? So we need to come up with a simulation that would be fair. A simple way would be something with 6 sides. We could use a dice. Everybody's got a number. Whoever rolls on, whoever person number 2 is, gets to pick where we go to lunch. Okay, so I would use a dice, or a die, singular. A die for that one. Robot stands up. It's equally likely to step forward with its left or right foot. So now we have 2 choices. So think of a simulation that would be good for 2 choices. I would probably choose a coin for this one. Heads, the left foot goes. Tails, the right foot goes. In a computer game, there are 3 tunnels. Each time the level loads, the computer randomly selects one of the tunnels. So we need something with 3 tunnels, 3 choices. You could have made a spinner with 3 sides. We could use a dice and say 1 and 2 would be 1 tunnel, 3 and 4 would be another tunnel, 5 and 6 would be another tunnel. Okay, so a lot of choices there. Maybe a spinner would be easier. Make a spinner, use a paper clip, 3 equal spots. It doesn't matter. There's a lot of different choices. 4 buses. Okay, so now we need something with 4, so dice doesn't really work good. It's kind of got to be a multiple of 2, 3, or 6 to work with the dice. Maybe you could use slips of paper, or different colors of paper, and then you draw them out of a bag. Each color represents which bus you will be on as a math teacher. Okay, if you have 4 buses, you draw a card, that's the bus the math teacher will go on. So whatever you think there, again, lots of possible choices for that. All right, good summary again on bottom page 48. Your assignment is page 49 through 51. 49 through 51, 5 problems, all right? Make sure you are doing the homework and then watching the videos to be sure you got the answers correct. Have a great day, guys.